Let's try that again. Thank you. So virtual residency 2022 workshop, Wednesday, June 29th, deploying community codes with Josh Gyllinsky. Go ahead, Josh. Josh, if you're talking, we can't hear you, or at least I can't.
How about now?
Perfect.
Excellent. Yeah, so thank you for the introduction. So my presentation is on deploying community codes. This is the fourth presentation of this type in the VRP series, previously presented by Prasad, Martin, and another Joshua. These are meant to be high-level overviews, not extremely technical, and they're meant to give you kind of a starting place. And obviously, we can't cover all scenarios. There are much better resources when you really want to dig into a specific solution. However, this will give you a good starting place. So what do we mean by codes? So we're talking about usually open source software that is computationally intensive, meant for scientific analysis, often written by researchers, for researchers, in the past scientists and engineers, but that's expanding to all sorts of different disciplines, which is pretty exciting. They tend to be free, sort of, varying licenses. They're not necessarily always free, so you'd have to verify that, and I'll talk about that in a moment. And they tend to be written in for specific platform that can be deployed. This is known as POSIX. So for POSIX compliant software packages, these are Unix-like operating systems, mostly. The ecosystem of these codes can be placed at almost any level of the stack, from operating system, environmental modules, complete programs, modules and plugins that might even require other programs, or just straight user scripts. And they tend to stack as we go through time, and people add upon them to, just like other forms of science, as you know, we stand on the shoulders of giants, and as we build upon that, the structure gets more and more complex. However, as this XKCD cartoon, and I'll have several of them, illustrates, they sometimes are precarious in their construction, and depending on how you deploy your software, your community codes, you can run into problems. So it's important to use best practices for that. Why might someone need community codes? Well, they can handle all sorts of different operations. For data processing, these tend to be the lower level libraries for matrix operations, your fast Fourier transforms, linear algebra, other numerical libraries, as well as very specific, more complex calculations and algorithms for weather forecasting, molecular dynamics, computational chemistry, bioinformatics, astrophysics, etc. And they tend to create a lot of data, and that data tends to often need to be processed again. These can be in the form of both commercial and community programs, and they might add into them as you're deploying software packages for your systems. Whether this presentation applies to both kind of users as well as entry level. But you need to be aware of the license available, whether it's available for just a specific user, the department, or the institution, what time duration that includes, whether or not you're allowed to do analysis and comparisons of those programs. There are certain commercial programs that don't allow that, and I won't name them. There also might be additional licensing validation requirements that also needs to be a primary concern as you're deploying these codes. And they often are segmented into modules for the commercial with varying levels of support at the various tiers. For community codes, they tend to be written by researchers for researchers with support and stability of varying levels. Now, this doesn't necessarily mean that they're buggy, but it might mean that they're not tested for your platform. This is also something to be aware of. And many larger programs now offer both a professional version as well as a community edition. So you might need to be aware of that as well. For community codes, they come in all different languages. More recently, a lot of stuff seems to be written in Python, R, and Julia. Older software tended to be written more in C, and if we go back, a lot of the Fourier transform stuff might be in Fortran and other things in Pascal and COBOL, but it could be written in anything. And they tend to be broken up depending on the specific use of the user, whether it's numerical, scientific, or visualization. These are just some of the ones that have previously been mentioned in other earlier versions of this. For management, and as I mentioned a moment ago, for management of commercial codes, it's important to be aware of, when you're deploying it, the specific number of active seats, and you need to be in a situation where you might be able to maintain and monitor that those licensing requirements. Ones that have these types of requirements might include Gaussian or COMSOL, for example. When you're deploying, it's important to be aware of what type of machine. And this is something that new users on HPC or cloud or other institutional cyber facilities are not necessarily aware of. But there are significant differences between a deployment on a personal machine where you really own everything, or a shared machine, and what you're able to access at hardware-wise, and the software stack and speed as you move to the networking for a remote. When you add on virtual, whether it's a virtual machine or a hypervisor, and what type of account restrictions there might be, as well as not only during the deployment, but also during the runtime, whether that requires additional scheduling information such as Slurm or other systems. For deployment concerns, you really want to know, is this really something for multiple users? It might be that a user comes in and says they need a specific tool, and the underlying requirements of that might have broad reaching effects on other users. And it may turn out that there are other users would also benefit from them. But if they don't, you need to know how that would happen. If there are issues, whether you can kind of roll back those processes, what is that management plan going forward? You, as the person deploying it, might not even be with the institution for the entire duration of the project. So what is kind of that closure and lifecycle processes? Where's the storage? And who has access to it, as well as any new security concerns that might be introduced. And where are you even getting the software? What's the media and who maintains it? That might be on a Git repo, or it might be a CD that the researcher had. For the responsibilities, it really depends on the specific institution's facilities. But if you're trying to install on a machine that you own, you're the administrator, so you just install whatever you want. But if it's someone else's machine, you're likely a limited user, so you either have to ask the administrators, or if you're allowed, you're going to need to install locally. And you may also have to use scheduling and other resource allocation requirements for processor or other stuff for whether or not you have additional hard drive space, etc., quotas, requirements. And ideally, as you're working through it, you're documenting this process. You want to make sure that if you find an incompatibility, that this is a patch that can be used by future users. So it's documented. And if you did make a question on a public forum or some other accessible ticket, please close it, and please add the solution. There's nothing worse than being so close to having the answer to installing your software package and know that someone else had solved it and you have no idea how they were able to do it. So if you kind of pay that forward, you'll benefit too from future installations, I'm sure. As an individual user, you probably are familiar with installing from source, whether that's with the autoconf, the /configure make and make install setup, or with the CMake methodologies, or just dropping the deployed software as a binary. This might be at the OS package level with deb or RPM or some independent package manager, brew. If it's a library based thing, for example, in Python, you might have Condo or other similar things, or pip. And you might have a standalone package. Flatpak and app image are examples that are starting to become more prominent. And actually, later in this presentation, I'll show how easy it is to make an app image. But as you're installing, if you are installing with broad-reaching full system deployment, you often will end up in what's colloquially described as dependency hell, where the packages tend to have shared dependencies that all require different versions, and they're all incompatible, or some level of incompatibility. So the real question is, how can we deploy while mitigating this concern? One of the ways that in industry and in some academic labs are used are virtualization tools. You'll see stuff with Docker, I think was mentioned at an earlier presentation, VMware on a local machine, VirtualBox, QEMU, Red Hat's virtualization tools and Oracle tend to be used as well, with varying levels of kernel integration for KVM and LXD. Visor you're probably not familiar with. That tends to be more ARM and going forward RISC-V, I believe, CPUs. But if you're interested in that, you might want to look into this. And for HPCs particularly, because the other ones, the way they were constructed, let's say, maybe have some flaws that Singularity, and now renamed as Aptainer, solves. So that's something that if you're not actively using, please check out the documentation for that. They all have varying levels of either integrated or complementary virtualization management tools. You've probably heard the term Kubernetes or Docker Swarm or Vagrant as deployment management, as well as virtualization management tools. So that allows you to produce kind of an entire operating system. So it would be the same setup whether you own the machine or you are running the virtual machine, of which if you had administrator access, you'd use kind of standard operating system level deployments, such as DNF for Red Hat or the apt suite for Debian. Actually, at the University of Rhode Island in the electrical engineering or ECBE department, we use Gentoo and eBuilds, and that allows for a more easily modifiable install script for the package, so that when deploying updates, the correct software gets installed without unarchiving and then re-archiving each package manually. You can also use what are called environmental modules. These allow one to change the software at the user level. Very common would be the TCL or Tickle. I think some people pronounce it as that, for loading and unloading these specific settings, so that when they have a change of the distributed software, it doesn't necessarily affect the other users. Another more modern version is LMOD, which is based on Lua, and a lot of labs seem to be moving to that. If you end up using, I'll mention in a bit, Easy Build, for example, you might have that as the base, as it doesn't necessarily require, actually neither of them necessarily require root permissions, which is why you might want to use this as your solution. So you can kind of break those up to, if you're relying on an external package management where you're bringing in your software and building it, if you're using some form of package management that gets included, or you have your deployments for building your software as part of the software management, or as part of the software package management, such as Easy Build SPAC or others. As you're trying to decide how you want to automate building your software packages, you have to be aware of how much time it's going to take. There's definitely a point of no return where you're not going to get that benefit for spending a couple of days maybe to make sure that something that's never going to be updated is completely maintained forever. But it's not just your specific use case. If you're writing software as a researcher and it's going to be able to be deployed, you also can add in the amount of time that other researchers will be spending to try to install your software. So in previous VRPs, Auto Tools, the RPM, SPAC, and Easy Build were people have gone into in great depth. So I'm going to leave it to those presentations because the software changes. So if you're looking at this next year, the specific install method might not be exactly the same. So instead, at the moment, what I'll talk about is some of the stuff that I've been using for deploying for kind of a middle ground for deb packages. This is what Ubuntu Server uses, as well as if you were deploying for a user who needs some integration to their mobile platform, they can use a fork you might not have heard of called Mobian, which allows you to run it on your phone, so that you can have kind of that complete integration between some deployed sensors with incoming data with a mobile modem uplink into the university's data center, so that you can process that with your implemented data flow. It's as simple as creating a folder with the necessary software. You need to make sure that whatever libraries are necessary for implementing it, that they're there, as well as a control file and a post-install file. And then it's just a simple dpk deb to build your package, and then that can be deployed. The other one is to use kind of an app image package that, instead of being an operating system level, you might want to look into software management being a standalone installable program. So similarly, as long as it has whatever libraries you need, effectively your shared libraries become static, even though they're not necessarily. And you can place it into a single folder and use the app image builder, and you end up with a single file that you can deploy. Unlike deb, which will solve for whatever your requirements, the expectation is that all your necessary requirements are included in this single file. Depending on the type of setup you have, you probably will be using Singularity as or Apptainer. This change happened in the last couple of months, so you might not be aware of it. It was actually forked and renamed as it moved into the Linux Foundation. So expect big things from that container setup. going forward. The important parts are that it supports cryptographic signatures and encryption with a immutable single file container, and has been developed in such a way to easily make use of GPUs, your high-speed networks, as well as various other parallel optimizations that will often be found in clusters for compute. The other types of deployment systems that you'll often see are ones of Easy Build and SPAC, both of which are fairly well documented and can be deployed in your user directory without being root, provided you're allowed to do so. And they're both more or less designed from the ground up for scientific programs and HPC. And they both kind of use varying pre-built recipes, where Easy Build, you'll use your .eb file, and there's some nuance in copying that over and making it acceptable for your program, and I think that's changing as well. And SPAC as a single command on the CLI, where the notation is a little difficult, I think, for new users, but it turns into a single command that I think they call it the concretizer, will generate the actual file. And then it will process that to figure out all the necessary dependencies so that in neither case you have to worry about that dependency hell issue. So I'm not sure how we're doing on time, but when you start the deploying process, you really just kind of a highly generalized version. You want to make sure that the actual software meets your needs. You want to identify that you're using the correct version of the software, that the resources available that you have access to will meet those needs. And almost all of these programs will have significant amounts of documentation already available. So go over that and see if anyone has made notes of security concerns that might be applicable for your setup or configuration or other deployment parameters. And document anything that's changed, identify any necessary processes for that upgrade, and make sure that all the authorizations, policy, et cetera, for the software's ownership and its life cycle on the university's resources are accounted for. And once the deployment process is generally understood, you can follow that plan while keeping track of any possible issues you might encounter, and schedule a follow-up with the facilitators to make sure that the software is meeting your needs and working correctly for the university's resources. Don't forget to ask questions. A lot of this stuff is developed by people who spend 24/7 working on it, so they don't necessarily know what a newcomer might not understand. So you can find places to ask questions by just going to the main page of whatever software community codes you're looking to deploy. There's often a Slack, a Discord, an IRC, or a forum that could be available. Sometimes it's just an email user group. So add yourself to that and follow along and kind of ask questions. And also see if anyone else in your institution or other institutions will, I'm sure, be most likely happy to collaborate and answer your questions as you're trying to set it up. Here's some of the references, and I'd like to answer any questions. And it looks like there's good stuff in the chat. If there are no questions, yeah. Thank you.
Thank you, Josh. And hang on, just double checking something. Okay, Prasad, are you ready to do your presentation?
Yeah, sure.
Okay, let's go ahead and do that then. And you're driving the slides, right?
Yes, sir.
Okay.
I guess there were some questions for Josh. Do you
Oh,
want to go
are there? Hang on.
about easy build and spec?
Oh, yeah. Josh, do you want to go ahead and answer the questions in the chat?
Sure, I'll try. I'm looking for the questions though. I couldn't see chat while I was presenting. I'm sorry if people asked stuff. There's a question about maybe benchmarking your setup. That's a great thing to do, especially if you're going to move from your local machine. I think there was a panel earlier today where they were talking about first trying on your local machine, then before deploying. So it'd be good to look at any speed ups you have, as well as a tool in the next presentation you'll see as part of maybe to optimize as you're debugging your code. Then there's some other links about useful articles. Yeah, the IEEE journals are excellent tools for this. How many applications you have set up on SPAC? How many on Easy Build? I'm not sure your question.
Joshua, you mentioned you use SPAC and Easy Build, or maybe I misunderstood.
Those are the ones that have that tend to be used.
Okay, but at your facility, at your
Oh yeah, I think both are used in varying.
okay,
Yeah,
just basic calibrate, half is SPAC, most of them Easy Build, just generic, nothing specific. Thank you for paying attention to the question.
yeah, definitely. Actually, what's the only thing that is really unique about our systems is Will Simino, our sysadmin, maintains his own kind of wrapped version of Gentoo, and he tries very hard to make sure that we don't need to deploy kind of containerized setups. So he uses what's called eBuild and lets that open in Portage. And if you're curious about that, so that everything can be built from source, I can reach out to you, or if you reach out to me, I can get you in touch on that too.
Thank you, I will.
Yeah, definitely. And then there's one other question. Is there a best place to start search for answer to question when deploying software? Stack Overflow is fantastic, as you mentioned in the question. Google, just a generic search engine, will often find stuff. Yeah, I think just searching, you'll probably start to encounter stuff. That in itself is a kind of a skill. But also, if you know of a specific program that you want to use, almost every open source project that has more than a handful of users will have some form of community interaction, in my experience at least. So if you reach out to them as you have problems, if you can't find anything else, they will be, quite literally the experts. But every institution, or most institutions, will have people like those on this call who also will have varying levels of skills for your specific problem. Yeah, and another +1 for Stack Overflow. And I am now, I've taken up all my time. So thank you. You can reach out to me and I'll do my best to answer any other questions.
All right. Thank you, Josh. What I'm going to do is I'm going to go ahead and stop the recording and then restart it so that Josh's talk and Prasad's talk will be separate. So give me just a moment.